everybody. Let's give this problem a try. So I have a frame with pin supports here. So let me just label these. So that's A, so I'll call this B and C. Okay, so you could just start with the free body diagram of the entire structure. I'll just draw it as a square, a rectangle. Okay, so there's this pin over here. So I'll just decompose that reaction into X and Y components. There's the pin at C, which I will decompose into X and Y components. And then there's the 3 kilonewton load over here. Alright, so let's solve for those unknowns. And already I see that at most we can have 3 equations for 4 unknowns. So it's statically indeterminate. We won't be able to solve for all 4. But let's see what we get. Okay, so in the x direction, bx, cx. That's it. Y direction, by, cy, minus 3 kilonewtons. Let's sum torque about anywhere we want. How about over here? Okay, so there's torque from this, which is here to here is 1.6. So that's minus. Minus because about this point it creates a torque going this way, which is in the x is here, y is here, so z is x is here, y is here, which means z is this way, and this force would create a torque going in the negative z direction. Okay, and then this force creates a torque also going in the negative z direction, so minus 1.2 times bx. Okay, and then that's it. Let me point out the unknowns here, 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 here. So let's solve for bx first. Okay, so that's minus. Okay, so just punch that in the calculator. Well, let's see. That's like 16 over 12, which is like 4/3. 4/3 times 3 is 4. Okay, so that's negative 4. Take that number, plug it in right here. Cx is minus bx, so that would be positive 4. Okay, and then we don't have enough equations to solve for the other 2 unknowns. So what do we do next? Since it's a frame, we can break it apart. Okay, so then there's space over here. Okay, so there's this part over here, and then this part over here. And then, actually, we already know these. Let me fill those in. So Cx is 4. Cy, we don't know. Bx is negative 4. By is unknown. Okay, and then let's not forget this tension over here. Actually, that's known, 10 kilonewtons. 10 kilonewtons. All right. What else? Okay, see this right here? I'll just call this pin D. So when we break it apart, now pin D would have reactions. I'll just decompose that. However I draw the arrows here, I have to draw them equal and opposite over here. Oh, there should be X. Okay. And then let's not forget the 3 kilonewton load. So because the load is acting at a pin, when we break it apart, we just put that force either here or here, not both. So you just pick one or the other. I'll just put it over here. Okay, so there we go. Now, what do we do? For each member of the frame, we can write as many as 3 more equations. Right, so let's say here in the x direction, what do we have? Minus 4 dx, And then, let's see, we need to know this angle right here. I'll just call it theta. Let's look at the this triangle right here. I'll just draw right over here. This triangle. Okay, so if I call this theta here, this is 0.6 and this is 0.8. So theta, tangent theta is opposite over adjacent. All right, so then arctangent of that gives you the angle. Just punch it in the calculator. So now we know the angle right here, which is right here. Okay, so then this would be minus 10 kilonewtons cosine theta. Okay, and then y direction, by minus 10 kilonewtons sine theta plus dy minus 3 kilonewtons. Okay, now let's sum torque about somewhere clever. So if we sum torque about here, then there will be torque by this, 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 and this, two of which are unknown. If we sum torque about here, then there's torque from this, 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 two of which are unknown. But if we sum torque about here, then there would be torque from this, this, and this, only one of which is unknown. So I think that's the cleverest choice if we sum torque about point D. Okay, so there's torque from this, which is, the lever arm is 0.6. So 0.6 times only the component this way, perpendicular to that lever arm, which is adjacent to the angle. So then 10 cosine theta. Okay, so that's the torque from this. And then there's torque from the 4 kilonewton reaction, and then that's 1.6, 1.2, 4 kilonewtons. And then there's torque from By, which here to here is 1.6 minus 1.6 By. Okay, so then let me point out the unknowns here, 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 here. Okay, so right here, solve for By. So now we know By. Take that value, plug it in right here, then you can solve for dy, and then we can solve for dx immediately. Okay, so now we know by dy dx. Okay. Let's see. So that's actually all we need for this particular problem. If you wanted, you can keep going. Not necessary for this particular problem, but if you kept going, you can write equations for this because we already know dx and dy. So there's only one unknown left right over here. So then you can just write one more equation to solve for this remaining unknown. Right, like you can sum forces in the y direction and then you'll get it. I'll just jot it down real fast. So, okay, this was theta, right? So plus 10 kilonewtons sine theta minus dy equals 0. And this is the only unknown left. Okay, so now you know all the reactions everywhere in the frame. This particular problem, we're interested in what's happening here at point A. So what we do is we cut through over here. So let me draw that. Right, so we cut it over here. And then, let me look at the picture one more time. Okay, so we have this by, which is known, and then for the other section, there's all the other stuff happening. Okay, so when you cut it here, you expose the internal forces and moments. Shear, axial force, bending moment. Shear, axial force, bending moment. Okay, now you don't need to analyze both sections, just one. So which one? This one or this one? I would pick the one that looks easier, which maybe I would argue this one looks easier to analyze. So let's just stick with that one. Okay, maybe I need to get this number, which I just have to punch this in the calculator right here. Okay, so it's just all of this divided by 1.6. So actually, let me get that number right now. Okay, so it ended up just By is 6. Okay, so By is 6. So we know this number, 6 kilonewtons. Okay, so now if we focus on this section, we can solve for the unknowns. Okay, so in the x direction, -4 plus p. In the y direction, 6 kilonewtons minus v. And then that's some torque about anywhere we want. How about right over here? So there's torque from this, and then how far is this? Let me look that up in the picture. 0.8. Okay, here to here is 0.8. So there's torque from this, negative 0.8 times 6 kilonewtons. And then there's no torque from this or this or this, about over here. But then there's this couple, which is in the positive direction. Okay, so let's solve here. So P is 4, V is 6, M, bending moment, is 4.8. Okay, so there we go. Okay, hope that was helpful. See you in the next video.